Hello everyone, my name is Priyanka Agarwal and I am a PMRF research scholar at Indian Institute of Science. I am currently working in chemical engineering department. So I am here to take solving session for the week 9 and for the course Differential Equation for Engineers, which is taken by Professor Srinivasa Manam from IIT Madras. So in week 9, if you see in the lectures, he has covered wave equation, how to solve wave equation, one dimensional form. So we are also going to look at some examples on solving wave equation, as they are also there in your assignment. So let's go for a quick recap. So wave equation is of the form, if we write it in one dimensional, u t t minus c square u x x equals to 0, where x belongs to r and t is greater than 0. And here c, constant c, is given by t by rho, where t is the magnitude of the tension. So this has already been explained in the lecture, so I will not go through it again. If you have any doubts, please revisit the lecture, or if you have some specific doubts, you can ask now. And this is the density. Now along with this, we are given initial conditions. Initial conditions are u at any x but t equals to 0 is given by some function like this, say fx. Again, x belongs to u, real number, and then du by dt at x comma 0 is equals to gx, where again x belongs to r. So for this, he has shown in the lecture the solution using D'Alembert's solution. D'Alembert's solution, where we do the transformation of variables. So transformation has already been taught in the previous sessions. So I'll directly just go through it, where xi can be written as x minus ct and eta can be written as x plus ct. And when we apply this transformation, the wave equation reduces to u of xi eta equals to 0, and this term can be solved. So the general solution for the wave equation in one dimension is given by u at nx comma t equals to c1 x minus c2 plus c2 x plus ct, where C1 and C2 are any arbitrary constants. Now you see this is the general solution, and if we just know the value of C1 and C2, we can actually get the solution. So for that, what is done is we use this D'Albrecht's formula and find the solution. So as you would have seen in the lecture, the general solution, that is how C1 and C2 are written. First, let me just tell you that also. So we know that C1 of x can be written as 1 by 2 fx minus 1 by 2 c and x0 to x, g of x, let's change some variables, so g of s ds minus 1 by 2 c2 at x0 minus c1 at x0. And similarly, c2x can be written as 1 by 2 f of x plus 1 by 2c x0 to x, g of s ds plus 1 by 2, again this term c2 at x0 minus c1 at x0. And if we just substitute these two over here, we can get the value of u, and therefore u comes out to be 1 by 2 f of x minus ct plus f x plus ct plus 1 by 2c integral x minus ct to x plus ct g of s ds. This is when t is greater than 4. So this is the required solution. Okay. Now here t is greater than 0 and x belongs to any real number. Now we solve for all these equations, and when we just apply the boundary condition, that is for t greater than 0, this is valid, but what if for t greater than 0, somewhere we will be solving for x less than 0, and somewhere we might be solving for x greater than 0. And in those cases, in lectures it has been shown that if fx and gx has to be extended as odd functions for x less than 0 side, and for x greater than 0 if they have to be extended as even functions, what does the solution actually look like, right? So this has already been shown in the lecture. Just for the sake of completion of this story, I will go through it. I'll just briefly go through it. And okay, so you see, if these are extended as odd functions, so that means in that case u of t comes out to be as 1 by 2 f of x plus ct minus f of ct minus x plus 1 by 2 c ct minus x to ct plus x g of s ds, where x lies between 0 to ct. Where x lies between 0 to ct. And in the other case, 1 by 2 f of x plus ct plus f of x minus ct plus 1 by 2c. So when it goes from x minus ct to x plus ct, g of x ds. This is when x is greater than ct. So this has been already shown in the lecture how to get it. Now the other case has also been shown when it has been extended as an even function. And in that case, what is that form of solution? Let me just write it for you. So in this case, u of x comma t can be written as 1 by 2 f of x plus ct plus f of ct minus x plus 1 by 2 c, and this goes 0 to ct minus x g of s ds plus 0 to x plus ct gs ds. So this is the case when x lies between 0 and ct, and the other case when x is greater than ct, then this takes this form: x plus ct plus f of x minus ct plus 1 by 2c x minus ct x plus ct g of x ds. This is the case when x is greater than ct. Okay, so this also has been shown in the lecture how to arrive at this. So basically, let's just jump to questions now with this background. If you have any doubts till now, please let me know. I will just wait for a minute so that you can unmute and ask. Okay, no questions, that means we can proceed. Right? So let's look at this question where it is given that wave equation is this, where we know that x is greater than 0 and t is greater than 0, and we are given the initial conditions. Which are u at x comma 0 equals to cos square x, where x is greater than equal to 0, and ut x comma 0 is 0 for x greater than equal to 0. And boundary condition is given u 0 comma t equals to 0 if t is greater than or equal to 0. So we have to solve this problem. Okay. Now you know that wave equation is actually of the hyperbolic form, which we just go to the normal form. It is actually b square minus 4ac is less than 0. So this wave equation is of the hyperbolic form. We should not forget this thing. Okay, so we already know how to solve this because we know that general solution is of the form where u can be written as summation of two functions, where c1 is function of x minus c2 and c2 is function of x plus ct. Now if you compare it with the general equation where this is u dt equals to c uxx, c square uxx. So c square is 4, so therefore c can be written as 2. Right? So we have c equals to 2 here, and then fx can be written as cos square x and gx is 0 in this case. Now if we just look at the c1 and c2 expressions, c1x can be written as 1 by 2 f of x minus 1 by 2 c into x0 to x g of s ds minus 1 by 2 c2 x0 minus c1 x0. Okay, so you know this function is 0, so this term vanishes. Similarly, if you write c2x, it will be 1 by 2 f of x plus 1 by 2c x0 to x gs ds. Again this term vanishes. This term is 0 minus plus 1 by 2 c2 at x0 minus c1 at x0. Okay. Now we can just add and get u. So u x comma t can be written as 1 by 2 f of x minus ct plus f x plus ct, and the term containing this 1 by 2c x minus ct to x plus ct gs ds is 0. So now we are only left with this term, and what we know is that fx is cos square x. So we can simply replace here f with cos square, and that would be our solution, right? Okay, so let's do it. U of x comma t can be written as 1 by 2 cos square x minus ct plus cos square x plus Ct, right? Now we can simplify this further. Now we know that sin 2x can be written as 2 cos square x minus 1, right? We can use this then. Cos square x can be written as 1 plus sin 2x by 2. Right? So this can be written as 1 by 2, 1 plus sin 2 x minus 2 ct over 2 plus 1 plus sin 2x plus 2 ct over 2. Okay. So what does this become? Let's take 2 common. This becomes 1 by 4 2 plus sin 2x minus 2 ct plus sin 2x plus 2 ct, right? Now this is sin a minus b form and this is sin a plus b form. We can again expand it. So this becomes 1 by 4 2 plus sin a cos b minus cos a sin b, and the other term becomes sin a cos b plus cos a sin b. Okay, now these two gets cancelled. What are we left with? 1 by 4 2 plus 2 times sin 2x cos 2 ct. So this becomes 1 by 2 1 plus sin 2x cos 2 ct, right? Then we can again simplify it because sin 2x can be written as 2 sin x cos x, and then cos 2x can also be written in sine form. But I guess we leave at this point only because it can be solved again. I think I made a mistake here in this, but it's not a mistake actually. Now we know that value of c is 2, so we can actually substitute c x equals to 2 and written is 1 by 2 1 plus 1 by 2 1 plus sin 2x cos 4t. Okay. So this is the solution. Okay, now when is the solution valid for the change? X greater than Ct or x is when this is between Ct. So now to do that, you could always go back to this. Okay? And here we have solved actually for so we have actually solved for x greater than Ct, but same thing can be similar thing can be done for x less than Ct. So this is for x greater than Ct, or we can say x greater than 2t, and similarly u of x comma t can be solved for x less than 2t but greater than 0. So you can simply use this. Okay, see, in all these solutions, g function is 0, so these all vanishes. So the only terms which we are left with is either this or this. Now if you see our function fx is cos square x. Cos square x is odd or even? Cos of cos square x is always an even function, and in that case we can write this as the solution. So only in this the sign changes. Okay, so here minus sign will come in one of the time, and then similarly we will solve for it. For now we will solve another question. So we have to solve this question where it's given that this is the Cauchy's problem, where x varies from minus infinity to infinity. Now we no longer lie in the domain where x is greater than 0, and we are given fx, this function, as a sin x, and g of x is given to us as 0. Okay, so these are our initial conditions. Initial conditions are given. So now again from this D-Elliot's formula, we can write ux to be a by 2 f of, it's in similar case as the above. So it is now a is common, sin x plus ct plus sin x minus ct. So here the value of c is not given, and if you simplify it, so again if you just open it, then this is sin a cos b and cos plus cos a sin b. So this is then sin x cos ct plus cos x sin ct, and for the other part it is again the same term, sin x cos ct, but here we have minus cos x sin ct. So this cancels and it can be simplified and written as a by 2 into this, which is 2 times sin x cos ct, and therefore it becomes a sin x cos ct. Now if you plot these functions, this is something which you will get. So this blue curve is actually showing the function for u x comma t, and here this is shifted a bit backward. So this is for fx minus ct, and this is for fx plus ct. In this case we have assumed that c equals to 1 and a equals to 1. So amplitude we have considered of the wave has to be 1. Now you see at different times this wave is operating with a fixed node. So the node of this wave is fixed, but amplitude is changing, right? Amplitude is changing in this case, and amplitude, this is always between 0 and 1 in this case. Okay, so amplitude is always varying between this. Similarly, let's look at another problem where we are given, the only change from the above problem is that we are given f of x is a mod of sin x. It's no longer simple sin x, it is mod of sin x. So in that case, let's see. So again from this solution, we get this thing, right? And if we simplify, we will get this, similar as we got in the above case. Okay, so this is the solution for the velocity of the wave. Now, if you see carefully, here, just by putting this modulus sign, see now u is always, so we can again consider a equal to 1, c equal to 1. So you see that u is always greater than equal to 0. So this is not going in minus y, it says. And if you plot it for various times, you see that amplitude is between 0 and 1. Okay. And it is only about this only. Okay, so this is the solution for this particular case. Okay, now let's consider another question. So consider an infinite string with zero initial displacement. So that is, the displacement initially is 0, so we can consider f of x is 0 initially, at equals to 0, and initial velocity is given by this function g of x equals to 1 by a e to the power minus mod of x by a. And also given is the sketch. If a equals to 0.7, this is how g function looks like, that of positive infinity and minus infinity. This function decays to 0 and it is symmetric around x equals to 0. Now, if we just consider that these solutions, fx and gx, these extended functions, like if they have velocity, if they are like extended either as odd function or even function, so that is this fx and gx. Now let's first calculate g of x, which can be defined as 1 by c minus infinity dx gs ds. Okay. Now this can be defined as 1 by c. This g function is a unit, so let's take that out. Minus infinity to x 1 by a. 1 by a we have already taken outside. So we have e to the power minus mod x divided by a. Now what we know is how this mod x behaves, right? So for x greater than 0, mod x greater than equal to 0, mod x is x, and for x less than 0, mod x is minus x. So this is how we define this function. So what will this gx become then in similar ways? 1 by ac. Now e to the power integral minus infinity to x, where minus infinity to x, and this is e to the power minus of minus x, then it becomes x by a dx. Okay, this is when x is between 0 and infinity, and if x is greater than 0, Then first we have to integrate till this point where we can write it as e to the power x by a ds, and then for e0 to x we can write it as minus x by a ds. Okay. This is when your x lies between 0 to infinity, because the limits are minus infinity to x, so we break it down. For minus infinity to 0, we get mod x as minus x, so this becomes e to the power x by a. And for 0 to x, by e positive x, we have mod x equals to x. So therefore this term becomes e to the power minus x by a. Okay. So now this can be solved further. We can write it as, if we integrate this, what do we get as e to the power x by a divided by 1 by a. So a comes here, and minus infinity to x. And here what we get is same thing, e to the power x by a minus infinity to 0 plus e to the power minus x by a. Now here we get minus a, and this goes from 0 to x. Right? If you have any questions, please let me know. Okay. So if we take a common from everywhere, we will have 1 by c e to the power x by a minus e to the power minus infinity by 0, which is then 0, right? And here a we have already taken out common. Now we have e to the power 0, which is 1, minus e to the power minus infinity, which is again 0. Then we have this minus sign from a, and e to the power minus x by a minus e to the power 0, which is 1. Right, so this becomes 1 by c e to the power x by a 2 minus e to the power minus x by a, where x here is 0 to minus infinity, and x here is between 0 to infinity. Okay, so we have got g of x here. So with this we can write g of x plus ct. It simply will be 1 by c e to the power x plus ct over a, and the boundary condition will now act upon x plus ct. And here we will have 1 by c 2 minus e to the power minus x plus ct over a, and here boundary condition would say that x is between 0 and x plus ct is between 0 and infinity. Now just look at it. This condition can also be written as minus infinity c t, and this can be written as minus ct x infinity. Right? Similarly, what we can write x minus ct as 1 by c e to the power x minus ct over a, where now x minus ct lies between 0 and infinity. And similarly, we have this 1 by c, 2 minus e to the power minus x plus ct over a, 0 x plus ct, right? So this is x minus ct. Alright. Now, similarly, we can write this as x lies between minus infinity and ct, and in this case, x lies between ct and infinity. Okay. So final solution can be written as 1 by 2 g of x plus ct minus g of x minus ct. So the solution takes this form. So now we will have not only these two but 3, because now there is break between 0 and ct. So we will have to write this for 3 cases. Okay. When x lies between minus infinity and minus ct, then the other case will be when x lies between minus ct and ct, and third case when x lies between ct and x infinity. Okay. So I'm just writing it 1, 2, 3 and see, let's what 1, 2, 3 and are. So this 1 will become 1 by 2. For this thing, g of x plus ct was 1 by c. E to the power x plus ct over e. Now minus, for this case, g of gx minus ct. So this will be 1 by c e to the power x minus ct over e. Okay. So we have this 1 by 2c e to the power x plus ct over a minus e to the power x minus ct over a. And the second case, when x is between minus ct and plus ct, so in this case the function will become 1 by 2. So now this falls for in the second string, 2 minus e to the power minus x plus ct over a, and then this we will have minus 1 by c e to the power x minus ct over a. So this also becomes 1 by 2c 2 minus e to the power minus x plus ct over a minus e to the power x minus ct over a. And what the third case will become? Third case when x is greater than ct but less than infinity. So in this case, this will become 1 by 2. This is now 1 by c 2 minus e to the power minus x plus ct over a, right? And then we have minus 1 by c 2 minus e to the power minus x plus ct over a. So again this becomes 1 by 2c. This 2 and 2 cancels out, and then this, what we are left with is e to the power minus x plus ct this is x minus ct, no? Minus x plus ct by a plus e to the power minus x minus ct over a. Okay. So we have written these 1, 2, 3 for all these conditions, and if we just take c equals to 1 in this case, we get the actual solution. I hope it's clear to you all. Okay, so if you have any doubts, please let me know. Otherwise, we'll move on to the next question. Okay, let's look at the next question. Now, question says using the algebraic solution, solve y dt equals to 9 yxx, where x is bounded. It is between 0 to 1 and t is greater than 0. Initial condition, you are given that y at 0 comma t. So this is the boundary condition. 1 comma t goes to 0, and initial condition is y at x comma 0 equals to sin 2 pi x, and y t at x comma 0 is sin 3 pi x. So we have to find the solution for this. You can try yourself also, or if you want, I can also do that. Okay. So just see quickly what is all given. So we have C as 3 over here. Fx is given as sine of 2 pi x, and g of x is given as sine of 3 pi x, and we are given a bounded x. It's not a unbounded case. Okay. So basically, how shall we proceed in this case now? Anyways, we know that general solution is c1x minus ct plus c2 c1x plus ct plus c2x minus c. And we already know c is 3. We already know what form just this u takes in form of the solutions, which is 1 by 2 f of x, right? F of just x or no? So this is f of x plus ct plus f of x minus c2 plus 1 by 2c x minus c2 to x plus c2. Sorry. Okay, now you see f of x, is it even or odd? So sine function is sine 2 pi x or any sine x. So what if we have sine minus x? It is written as minus sine x, right? So sine is even or odd function. So sine is an odd function. Okay. So after knowing this, that sine is an odd function, we know what has been shown as the solution for our function. Already we have seen that, but for now just let's go through it. So we are also given the bounds of x, which is between 0 and 1. So x lies between 0 and 1. So x plus ct would lie between ct and 1 plus ct, where c is equal to 3. So x plus ct lies between 3t and plus 3t. This is also 3. Okay, so let's write down the solution. So u of x comma c t can be written as 1 by 2 sine of 2 pi x plus ct, right, plus sine of 2 pi x minus ct, right, and Then we have an integral 1 by 2c integral x minus ct to x plus ct sine 3 pi x 3 pi s ds. So we have this for x greater than ct. Now c equals to 3 everyone, right? So this can be written as we have this 1 by 2. Now this is sine 2 pi x plus 3t, and this is sine 2 pi x minus 3t over 2 plus 1 by 2c. So let us write it down, sine 2 pi x plus 3t plus sine 2 pi x minus 3t plus 1 by 6 x minus 3t to x plus 3t sine 3 pi x plus 3. So from here and again writing this as this is the case. This is what only x comma 2. Okay. Now let us call this integration as I. So if we look at I, what is it? X minus 3t, x plus 3t, and we have here sine 3 pi s plus 3t ds. Okay. So we know that x lies between 0 and 1. So this sine function is actually an odd function also, right? So integration of sine is cos 3 pi s plus 3t, and we will get divided by 3 pi with a minus sign, and here x minus 3t, x plus 3t. So this becomes minus 1 by 3 pi cos 3 pi x plus 3t. Okay, so basically this remains s only. There's no 3t here. Minus cos of 3 pi x minus 3t. This is our I. So final required solution becomes this is y of x comma t equals to sine 2 pi x minus 3t plus sine 2 pi x plus 3t over 2 minus 1 by 18 pi and then this term. You can also make it plus here and write that term into cos 3 pi x minus 3t minus cos 3 pi x plus 3t. So this is the solution. This is a y. Yeah, so this is the required solution. Any doubts in this? If not, we will close the session here. Thanks for attending this session. Thank you so much and bye bye. See you next week.